So let's remind ourselves of the equations that we have: minus 3h double dot of t over 2 h of t plus 3 h dot of t squared over 4 h squared of t equals 4 pi g times the density, and h double dot of t over 2 h of t plus h dot of t squared over 4h squared equals 4 pi g rho. So I think the usual trick here that's done, although in the metric we put h of t there, and usually I think they put h of t squared in there, but this it should still work the same. Let's see. We try to consider this kind of term, h dot over h, h dot over h, and call that f of t. So that's some function, or it's a definition. And so our equation now, well, first of all, f dot t, if they take a derivative of that, we then get h double dot of t, right, over h of t minus 1 over h squared, h dot of t squared. So that is h double dot of t over h of t minus this thing squared, right, minus f squared of t. And so what do we get here? F dot of t plus f squared of t is equal to h double dot of t over h of t. So we can replace some of these terms. I think we'll be going in circles a little bit here, but we should be able to get there. So these two equations become minus 3/2 times f dot of t plus f squared of t plus 3h dot square. I'll just write this as h, then we'll come back to this, over 4 h squared of t equals 4 pi g rho, and 1 over 2 f dot of t plus f squared of t plus h dot squared over 4h squared, 4 pi g rho. Let's see, h dot squared over h squared is here, but that's just f of t squared, so I should have combined that before. Let's do that now. So this looks like minus 3/2 f dot of t plus f squared of t plus 3/4 f squared of t, 4 pi g rho, and the second one looks like 1/2 f dot of t plus f squared of t plus 1/4 f squared of t. So we subtract one from the other, actually getting rid of rho. We'll get this factor h that's embedded in the f without the density. I have to think about that. But so we end up with 2 f dot of t plus f squared of t minus 1/2 f squared of t is equal to 0. 2f dot of t plus 3 halves. What's left over with these two? Twice minus a half, f squared of t, and that's equal to 0. So let's just write this out. 2 df dt is equal to minus 3 halves f squared of t. So separation of variables will give us df over f squared is equal to minus 3/4 in dt. So minus 1 over f equals minus 3/4. T minus some initial time, t naught. And so well, that's the age of the universe, the current time minus the initial time. So f is equal to 4 over 3 t minus t naught. And now we can finally write this in terms of h, right? F is equal to h dot over h. So we have 1 over h dh by dt is equal to 4 over 3 t minus t naught, or dh over h is equal to 4 over 3 t minus t naught in dt. And so we get the natural log of h equals 4/3 natural log of t minus t naught plus some constant. So h is equal to t minus t naught to the 4/3 times some e to this constant, or h is equal to, call it d, t minus t naught to the 4/3, which shows the time dependence of this h factor. So it's increasing with time, and so ds squared is equal to minus c squared dt squared plus this d t minus t naught to the 4/3 dx squared plus dy squared plus dz squared. So that's the scale factor, and let's look at this d in more detail, but that's what the function h looks like as a result of solving the Einstein equations.